All right, so we have another video on solve by elimination. The more we see this, the easier it gets. We want to eliminate either the x or the y from the equation. So we take a look at our equation. We have a 3x and 2x, a 2y, and a negative 5y. So using multiplication, we want to get the x's or the y's to be the same number, but with one positive and one negative. So this one's going to involve multiplying both the equations by a different number. I'm taking a look at the y's this time. A 2 and a negative 5. I can multiply and get those both up to a 10, and then the 10 and the negative 10 will cancel away. So to get this equation up to a 10y, I'm going to multiply everything by 5. So I have 15x plus 10y equals 20. Now this bottom equation is at a negative 5, and I want to get that up to a negative 10, so I'm going to multiply everything by 2. So it's going to give me 4x minus 10y equals negative 58. Okay, now we did the prep work, so our equations are ready to add together. 15x plus 4x is 9x. 10y plus a negative 10y cancels, so equals, and then 20 plus a negative 58 is a negative 38. And did you guys catch my mistake already? 15 plus 4 is not 9, it's 19. Okay, so now we keep solving for x, divide both sides by 19. Negative 38 does divide by 19 evenly, which is nice. We're going to get a negative 2. So we'll be able to avoid a fraction on our x value. Now to get the y value, go back up to the top equations and figure out which one looks a little easier. For me, maybe the top one looks easier. We're going to plug in that negative 2 for the x. So we're going to do 3 times negative 2. So again, we're taking this top equation and just plugging the number in. Plus 2y equals 4. So this gives us a negative 6 plus 2y equals 4. Let's solve for y. Get that y by itself. Divide by 2, and y is a 5. How do we represent our answer? As an ordered pair, the x is a negative 2, the y is a 5. That is our solution. All right, next one. So example 5, does this one look a little bit different to you guys? In our last examples, everything is lined up so nicely. The x's have lined up, the y's have lined up, the equal sign, and then the number on the end. So you may have to kind of move the problem around a little bit to get everything to line up. It's that plus 4 that's getting in our way. So I want to subtract 4 because that should be on the other side. So I'm going to rewrite the problem. I have 4x minus 3y equals 6. And then we have 2x minus 5y equals negative 4. So you see how much better that looks? All right, so let's eliminate the x's or the y's. It doesn't matter which one you choose. If we eliminate the x's, we can multiply the bottom one by a negative 2 to get 4x and negative 2x, or negative 4x. If we choose to eliminate the y's, a negative 3 and a negative 5, we can multiply to get those up to 15. One would involve multiplying by a 5, one would involve multiplying by a 3. We'd have to make sure we had a positive and a negative. So always pick the one that seems easier. I think it's going to be easier to eliminate the x's. So I'm going to multiply the bottom equation by a negative 2 so that I can get a negative 4x right here to cancel with that 4x. The top equation I don't need to change, so I'm just going to copy down 4x minus 3y equals 6. Multiply that negative 2 throughout the bottom equation to give us negative 4x. Negative 2 times negative 5 is a positive 10y. And negative 2 times negative 4 is a positive 8. All right, now we can go ahead and add our equations together. The 4x plus the negative 4x cancels. Negative 3y plus 10y is 7y equals 6 plus 8 is 14. Divide both sides by 7, and y is equal to 2. All right, then we take the y and we plug it back into one of our equations up here To me, I think the top one seems a little easier. It doesn't matter which one you plug it in because it will be a solution in both. So we have 4x minus 3 times 2 equals 6. Negative 3 times 2 is a negative 6. And then we just keep solving. Add 6 to both sides. Divide both sides by 4. And you get x equals 3. So our ordered pair, the x is a 3, the y right here is a 2. So this is actually our solution, 3, 2. That's where the two lines cross.